This video is produced by Sammy and
Kevin Burgess
for by Inquisition Press to support the workbook Sophomore Organic Chemistry 2 by Inquisition, available from www.byinquisition.org.
Halogenations of enolizable aldehydes and ketones is a simple electrophilic addition. It's very pH dependent. And under acidic conditions, if a ketone has an acidic hydrogen, an alpha CH, it will form an enol or an enolate, Sammy?
An enol.
An enol. If I add bromine, we get bromoketone. Similarly, I can iodinate under acidic conditions, I can chlorinate under acidic conditions, or I can even add nitrosyl plus to give a nitrosyl, which actually tautomerizes to the oxime. If we now consider basic reactions of enolizable ketones and aldehydes with halogens, well, the situation is slightly different. You see, if I form an enolate with a bromine on it, because of the inductive effect, the brominated enolate is less stable, more reactive than the enolate with no bromine there. And if I have two bromines, it's even more destabilized. So it will react even faster. If I take this ketone here, add a base to form the enolate, and brominate it, in the presence of excess base, the enolate will form again, and the more reactive enolate that's formed will brominate a second time. In other words, we get two brominations if there are two acidic CHs, if the reaction is done under basic conditions. Now, if we have three acidic CHs, how many bromines could we add?
3.
And something amazing happens, because you're right. We form an enolate, we brominate, we form another enolate, we brominate that, we form an enolate a third time, and we brominate that as well. And the amazing thing is, a hydroxide can add to the carbonyl, and we break a CC bond. That's shocking, isn't it, Sally?
Yeah, I've never heard of that.
Because the anion that leaves is stabilized by the 3 halogen atoms. And also really because it's sterically encumbered. It stretches the bond a little bit. So if I protonate the trihalomethyl anion, I get trihalomethane. Do you know anything about the solubility properties of triiodomethane?
No.
It's not soluble. Most things, like aqueous alcohol, and it precipitates out as a beautiful yellow solid. So people used to use iodine and base as the iodoform test to see if they had a methyl ketone before the days of NMR, for instance. So it means every time we see a methyl ketone and we add base and excess halogen, we ultimately lose the carbon and form an acid. Okay, so if I give you a series of ketones and ask which ones will form iodoform when treated with iodine and hydroxide, only the ones with the methyl group, alpha to the carbonyl, will do the iodoform reaction. So to a synthetic chemist then, this is great because we have flexibility. If we want to take this ketone and brominate it once, we would do that under acidic conditions. But if we want the dibromide of this ketone here, then we would use basic conditions. But if I have a methyl ketone under basic conditions, I can convert it to the carboxylic acid. In this example here, Sammy, where we have a keto and an alkene group in the same substrate, what might happen?
Bromine adds to alkenes.
Good. So in this particular case, bromine would add to the methyl group and it would add to the alkene. So we'd end up with the tribromide. In the same type of substrate, where we have an alkene and the carbonyl and treat with iodine, what will happen then?
Well, the iodine wouldn't add to the double bond.
It wouldn't. And what does the iodine and base do to the methyl group on the ketone?
It's an iodoform reaction,
giving us a carboxylic acid. And therefore, we can go backwards. If I ask you to make this brominated cyclobutanone from cyclobutanone itself, would you use acidic or basic conditions?
acidic.
If I want to make this tetrabromide here, would I do it under acidic or basic conditions?
Basic conditions.
And if I want to make this dibromide here, what would be my starting material?
Phenylethyene.
Or styrene, actually. Styrene, the same thing. And my starting material to form this trans dibromocyclohexane,
Cyclohexene.
and to brominate benzene, we start with benzene. Formation of these alpha bromo, alpha beta unsaturated ketones is an interesting reaction. If we start with an alpha beta unsaturated ketone and brominate it, we get the trans dibromide. But because of the acidic CH, an E1CB elimination is quick, and that leaves one bromine in and eliminates the one at the beta carbon.